Hi friends, welcome to Champion Series of CIB preparation. So without wasting the time, we'll start with the topic directly. We are today covering the objective questions on linear programming. So let's start with the first question. Objective function of a linear programming is. So first constant, function to be optimized, an inequality, or D is a quadratic equation. Now I'll give you 10 seconds and you have to answer it. I'll give the answer and explanation later. Okay. First your 10 seconds starts now. So start immediately. Think over it. Constant, function to be optimized, or an inequality, or a quadratic equation. Think over it. Think fast. A constant? No. Is linear objective function of a linear programming constant, or is it to function to be optimized? Everyone, yeah, you must type it fast in the comment section. Everyone type it in the comment section. I want the answers from everyone. Yeah, please type yes, yes, yes. Everyone is typing now. C, 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 B, B and C. Everyone is stuck between B and C. Okay, so the correct answer is, shall I give you? Correct answer is a function to be optimized. Remember, in any linear programming there are two functions. Basically one is constraint and second is the objective function. I'll teach all the topics at the end. Okay, firstly we'll solve the objective questions. Okay, and whenever needed I'll come to these definitions over here. So remember, important part, objective function basically is a target what we have to achieve. That objective function can be point number one, it can be directly remember profit, or point number two, it can be cost. So whenever the objective function is profit, we have to maximize. Always remember, maximize. And whenever the objective function is cost, we have to minimize. Okay, remember these two parts. Okay, I'll take the full topic at the end. Okay. So objective function of an LPP is basically function to be optimized. Okay, second point. The optimal value of the objective function is attained at the points. Now optimal value means what? See here, there are two values in any LPP. One is feasible value, feasible, F-E-A-S-I-B-L-E, feasible, and second is optimal, okay, optimal value. So these are the two values. Okay, so the optimal value of an objective function is attained at the points. Now you have to answer feasible. What is feasible? What is optimal? I'll answer you, or I'll give the answer from my side and explanation after this, after you give the answer. So giving by intersection of lines representing the inequations of the axis only. So only of the axis. Axis means this part. This is y and this is x-axis. This point. Is this the optimal solution? Second is given by intersection of lines representing inequations with x-axis only. Means purely on x-axis. Means this only where it cuts this x-axis. And given by corner points of the feasible region. So what is the feasible region first? Okay, I'll explain you that also. What is the feasible region? See here, important is you must you must understand what you are doing. Okay, otherwise what will happen, you will just go on moving here and there and learn mugging up. I don't want you to mug up. Okay, and CIB is not about mugging up. Okay, so see here, I'll show you what do you mean by this feasible solution over here. See here, look at this picture. This is a y-axis, this is a x-axis, and this blue region is known as a feasible region. These points are known as feasible points, or the points at which we get the feasible solution. Okay, then what is the optimal solution? Whenever I move from my z function, or the final function, objective function, from this point to this point to this point to this point, wherever I get, suppose it is sales, so wherever I'll get the maximum sales in these 3 points, 1, 2, 3 and this 4 also, wherever I'll get the maximum points, that is known as the optimal function. And if it is a cost, then wherever I'll get the minimum value, that is known as the optimal function. Okay, So coming back to our question, okay, so the optimal value of the objective function is attained at given by the intersection of the lines, given intersection representing inequation of the axis, given by the intersection of the lines representing inequations with x-axis only, given by the corner points of the feasible regions. Here this is the feasible region 1 and 2, okay, this is a corner point, this is a corner point, this is a corner point, and this is the corner, and this is known as a feasible, right? So which is the answer? Type A, B or C fast. Definitely not D. Okay. So A, B or C. In fact C and D can also be the answer. It depends what function you want. Okay. So A, B, C or D. Which one? Think. Everyone. I'll give you 10 seconds again. Is it with both the axes? Is it with only x-axis? Is it with the corner points, or is it at the origin? Give fast. Just now I showed you what is feasible region, okay? Correct. Now everyone is answering correctly. Everyone should answer. Type in the in comment section whatever answer you feel right. Type it immediately. I am watching it, okay? Because I want you to go by yourself to the exam. You shouldn't be dependent on something, okay? So answer is correct. C, right? Corner points, right? Just now we saw this corner points. These, okay, so answer is C. Now third, which of the following statements is correct? Every linear programming problem has at least one optimal solution. Every linear program problem, LPP, I'll just call it LPP now. Every LPP has a unique solution. Every LPP has two optimal solutions. Then it has infinitely many solutions. Means if an LPP has two optimal solutions, then it has infinitely many solutions, okay? If a feasible region is unbounded, then the LPP has no solution. So which of the following statements is correct? This is in case studies I have taken separately in one of the lectures, okay? Unbounded region. There are 6 case studies for bounded, unbounded, optimal, then point related problem, then point related feasible solution, right? Unique feasible. Got that point? So follow that lecture again. Okay. So which is the answer over here? What do you think? A, B, C or D? One optimal, unique solution, two optimal solution. If LPP has two optimal solutions, then it has infinitely many solutions. And third is if feasible region is unbounded, then the LPP has no solution. Unbounded, then no solution. So which is the answer? A, B, C or D? Type fast. Everyone must type it, okay? Because you have to answer the questions in the exam by yourself. Nobody will come for your help, okay? So start fast. I'm waiting, okay? Yep. Yes, the answer is C. If LPP has two optimal solutions, then it has infinitely many solutions. Means what do you mean by this? Okay, remember one important part. In the case studies I have taken, separate case studies which I have taken separately. See here, if this is a feasible region, okay, this is a feasible region. Let's see this, okay, and this is my objective function, means Z function we call it. I'll make this dark Z function, okay. I'll draw 2 lines over here, Z function. So if this Z function or the objective function, Z function is also called as objective, both the names one and the same. If this Z function is parallel to one of the lines, either this line or this line or this line or this line, okay. If this Z function is parallel to one of the lines, then it has infinitely many solutions, and then it has two optimal solutions at least, okay. So this is the answer. This case comes when the objective function is parallel to one of the lines of the feasible region. Got this point, everyone? Everyone okay with this? Type yes if you are okay with this, okay. You have got this point, feasible. Just now I showed you the feasible region in one of the problems, right? Next, a feasible solution to an LPP must satisfy all the problem's constraints simultaneously, okay. Means all the problem constraints simultaneously, okay. Number 2, need not satisfy all the constraints, only some of them, okay, must be the corner point of the feasible region, must be the corner point, okay. Means what is the feasible solution? Firstly, understand there are two types of solutions I told you. Feasible, right? And second is what? Optimal, right? Optimal, correct? So feasible contains everything, all the regions. See this, in this region, this here. What is the feasible? This point, this point, this point and this point. All are feasible. But optimal is only one. Okay? So need not satisfy all the constraints, only some of them. So we want it for feasible now. Must be the corner points of the feasible region. Must optimize the value of the objective function. Must optimize the value of the objective function. So is this the answer? So type, everyone, you should type A, B, C or D. Let me see. Must satisfy the all the problems constraints simultaneously. Means all the constraints should be satisfied simultaneously, only then it is called feasible. So is this the answer? Or B is the answer? Only some of them. Or C is the answer? Corner points. But corner points I have just shown you the example where it's parallel, right? So type, everyone, which is the answer? A, B, C or D? Let me check. Let me check. A, B, C, D or D. Everyone must type this. Everyone. I'll wait up to the time at least I get 10 answers. Fast. 10 answers I must get it. 5, 6, 8. 8 have been done. 8 have been done. Only 2. 2 more. Then I'll give you the right answer. Right. Now 10. Okay. Everyone must try these problems. Okay. So the answer is correct. Answer is A. Must satisfy the all problems constraints simultaneously. That is the basic logic of LPP, isn't it? See here, what did I tell you earlier? This optimal means all the points. Feasible means all the points, and optimal means only one. So if some point has to be the feasible, has to be in the feasible region, this point must satisfy all the constraints. Only then it comes under the feasible region. Otherwise, there is a point over here also, but this point does not satisfy the criteria. That's why it is not in the feasible region. Okay, got this point, everyone? So answer is A. Okay, so before going ahead, I'll tell you we are having the CAIIB selection batch going on, which will be coming on June 6th, 2022, 6 a.m. It will be starting at 6 a.m. So bank's timings are adjusted. Go for this batch immediately. Okay, I'll tell you how to go for that batch also. So how to go for that batch? Here, look at the fee structure and everything. The fee structure is heavily discounted now. Okay, I'll show you how to go for that. Okay, the fee structure is so discounted. Look at this. Where are we? Means it's an investment for lifetime, isn't it? See here, go to Adda 24/7. Just look at this. You'll see all these JAIIB, CAIIB exams, right? All these things over here, JAIIB, CAIIB. Click on JAIIB, CAIIB. See here, after this I'll be taking the remaining remaining questions also. Okay, so wait and check for these paid classes and wait till the end for the video. Okay, click on CAIIB. In CAIIB you'll see all the batches now which are coming up. Go for this selection batch. See this selection batch. Remember my code Y432, Y432. Okay, now you will see the magic of that code. See this code. The details of the batch are given. Okay, ABM, BFM and retail, all the batches are given. Okay, then after that, see this, look at the fee structure. 13,299. You will say the fees is heavy, but put the code and see the magic. Y432. Okay, remember, never ever forget this code. So Y432, once you apply this code, you will get a discount of what? 77% off you are getting immediately. 77. My God. Means have you ever checked on Amazon or anything? Have you ever got this 77% off? So from 13,299 you come down to 3058. Now this 3058, if you clear CAIIB, in how many months will you recover? Roughly your average income increases by 1300, roughly 2 increments, right? If you are at a clerical level, and if you are at officer level, roughly 1200 to 1300, single increment. Okay, so even if you consider that, you will recover this in how many months? Third month you are out. So 3900 is the third month, right? And you, how much are you spending? 3000. Only 3000. So go for it immediately. Okay. So now we'll come back to our come back to our questions now. Okay. So coming back, LPP, PowerPoint. Okay. Yeah. So now next question. For linear programming problem, minimize z equals to 2x plus 3y. The coordinates of the corner points of the bounded feasible region are A 33, B 23, C 2010, D 1812 and E 1212. Now this is a difficult question. So here what have you to do? Always remember how to solve this problem. Okay. First you draw this x and y. X is given, y is given, y is given. Okay, everyone solve this. Okay, and this is a z function. This is always known as a z function. Z equals to 2x plus 3y. Okay, this is the z function. Now what have you to do? Put the values of x and y everywhere. 3, 3. This is what point A. I'll write this point A over here. Okay, this is point A. Point B is what? B. What is this? 20 and 3. Point C is what? 20 and 10. Okay. D is what? 18 and 12. Okay. E is what? 12 and 12. Always everyone take your pen and paper in hand and try to solve this. Okay. Now we have to put the value of x in each one of them and find the value of z. Okay. And what have we to do? Minimize. Okay, where we get the minimum value, that is your answer. So 2 into 3, x is what? 3. 2 3 is 6 plus 3 3 is 9, right? 9 plus 6, 15. I am getting it over here. Okay, 2 into 3 plus 3 into 3. Got this function? Everyone type yes if you have understood this. 2 into 3 plus 3 into 3. Everyone type yes if you have understood this. Okay. Second one, 2 into 20 plus 3 into 3, right? 2 into 20 is what? 40 plus 3 into 3 is 9. So 49. So 49 is the answer over here. This 20 and 10. 2 into 20 plus 3 into 10, right? So 3 tens are 30 and 22 is 40. 40 plus this 70, right? 70. What is the next one? 18 into 2, right? 18 2s are 36 and 12 3s are again 36, right? So the answer of total of them is 72. Next, 12 into 2 24 plus 12 into 3, right? 12 3s are 36. 36 plus 24, 40 50 60. 60. So which is the optimal solution? We want to minimize it. Where is the minimum answer? A. Everyone should solve this. Everyone. I want everyone to solve this personally. Are you getting the answer 15? Everyone type yes if you are getting the answer as 15. Okay. Type yes if you are getting the answer as 15. Don't bluff. Okay. It's you who will be facing the exam. So don't bluff. Okay. Be very clear. Okay. So are you getting yes? Many of you are typing yes now. Yes. So answer is B, 15. Correct? Everyone got this answer? Please solve it yourself. Because if you are cheating, you are not cheating anyone else. You are cheating yourself. Try it yourself. Use calci, pen and paper. Okay? Move on. Because we have limited time. For a LPP, maximize z equals to 2x plus 3y. The coordinates of the corner points are A 33, B 23. Same coordinates, I think so. Same. Yes. Z 2x plus. Same problem is repeated over here. Now I won't show you the backslide. Everyone must try it now. I won't show you the fifth problem. Otherwise, what will you do? You will check that and just write the values. So what is the maximum value? Everyone must try this again. Put what did I say? Point, then x, then y, and put this 2x plus 3y. Okay. Now try it and get the answer. What is the maximum answer you are getting? Everyone. Yes. What is the maximum answer? I'll wait for your answer. Okay. Everyone must try x, y, then z. Okay. I won't show this slide now. Okay. I'll show you after 5 seconds. Once everyone of amongst you have tried, I'll show you after 5 seconds. Okay, I'll wait for 5 seconds because I want you to become the leaders, not the followers. Okay. Okay, now I'll show you. See this. See, this was x, this was y, this was z. So what was the maximum value? Z. And what was asked over here? The minimum value of maximize this. The coordinates of the corner points of this are. So it should be maximum value. Maximum value of z is, what is the answer? 72, right? Just now we saw it over here. 72. See, this is the answer at point D, right? So it should be maximum value over here. It should be maximum. Okay. So the question given is maximize over here. So you have to find the maximum value. It's that simple, right? So answer is 72. Everyone amongst you must try using this method. Okay. There is no other way. There is no other shortcut. Okay. Everyone understood this? Shall I move ahead now? Type yes if you have understood this. Okay. Then only I'll move ahead. Type yes, yes. Now I'm seeing yes, 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 yes. Okay, okay, yeah. People are typing just Y or S, Y or S. Okay, then also okay. Means it's a world. Today the world is of abbreviations, short forms, right? Means LOL, lots of what? LOL, right? Lots of laughs. Everything is a short form, right? Seventh. Corner points of a bounded feasible region of a LPP are these. Okay, these are the corner points. Let the z function be this 8x plus 12y of the objective function. Okay, match the following means what is the we have to do the match the following. So try this. How do you try this? Same logic again, because this is very important problem. These types you get it in exam always. So x, then y, and z, right? Z equals to 8x plus 12y. Got this? So now put the values of x and y again over here. X and y 0, 4. Then which one? Everyone amongst you must try same problem, similar problem over here. Then 6, 0. Then 0 it is 0. Then 12, 0. 12 and 0. Then 12 and 16. Then 0 and 10. Try everyone. Let me see who can try. Who comes first? Okay. That guy will get a chocolate from me. How will I give you? That's a separate thing. I'll tell you at the end. How will I give the chocolate? Who comes first? He'll get a chocolate. Okay, from me. So try it first. Yes, 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 yes. Who has tried? Yeah. Right. This Lena, yeah, you have tried. So yes, this person. Okay, you'll get the chocolate now. Okay, let's try. 8 into 0 plus 12 for the 48. Okay, 48. Then 8 6 the 48. 48 two times over here, because 12 into 0 is 0, right? Then third, 8 12 8 is a 96. Okay, because other part is 0. Then 12 into 8 96. 16 into 12, right? What is 16 into 12? Does any of the bankers remember the tables now? Okay. 16 into 12 is what? 192. 192 plus 12 is a 96, right? 192 plus 96. So 292 and 288. 288 will be the answer over here, right? Tables everyone must remember, but we always forget the tables. We have not learned the tables throughout our life, right? So next one, 0 into 8 plus 12 into 10, 120. So what is the answer I want? Match the following. The minimum value of z occurs at, which is the minimum value? Which is the minimum value? 2 points have the minimum value over here, right? So minimum value of z occurs at what? 6, 0, 12, 0, then what? 288, and fourth is 48. Okay. So minimum value of z occurs at, here we have to get all the 4 options over here. So where does this z value occur minimum? Is it at this point 60 or 04? Is there any option of 60? 60 is there. 04, that is also there. Both the ways you get this value. So both the answers, all the answers are possible over here now. Now check for second one. See here, whenever you get the confusing answer for the first, check for the second one. Maximum value of the z occurs at, so what is the maximum value? 288. So it occurs at 1216. Now check where is the 1216 answer. So this is 1216. So definitely A and D are gone now. A and D are gone because 288, what is the answer? This 1216. 1216 is not given over here in second. So only B and C is the answer now. Now third value. Maximum value of the Z is, what is the maximum value of the Z? 288. So they, here again both of them are common. So go for the fourth one. Minimum value of Z is, which is the minimum value of Z? 48 or 96? 48. So this is the answer. So your answer now becomes B. That is the correct answer. Everyone got this point? How to go in exam? Always you have to try with this table only. There is no other way out. Okay? So answer is B. Got it everyone? Next. The corner points of a feasible region are determined by the linear constraint equation this. Z is given. Conditions of P and Q so that maximum value of the Z occurs at points 15, 15 and 0, 20. So this is condition on P and Q. So what is the condition on P and Q? So that the maximum value of the Z will occur at 15, 15 and 0, 20. So this we want some condition for P and Q. So what is that condition? Everyone try it yourself. What can be, if you put P equals to Q, then what happens? P equals to Q. If you put that, then what happens? This is also 1, this is also 1. Let's see this one by one. P equals to Q, 1 and 1. So X and Y. So X and Y, maximum value 15 and 15. 15 plus 15 is 30 over here. So Z becomes 30 over here. And 0 and 20 occurs at both the points. We want both the points, okay? So this is 30 and 0 and 20 becomes 20 only. So this is not the correct thing, right? Second, P equals to 2Q. Now this is 2 and this is 1. See here, this is, we'll see the option B now. So this is P equals to 2 and Q equals to 1. So what happens now? 2 into 15, put this X. 2 into 15 plus 1 into 15, right? 15 plus 30, 45, you'll get it over here. And similarly for the other one, 2 into 0 plus 20 into what? 2 into 0 plus 1 into 20, right? 1 into 20. So it is 0 and 20. So again both are not equal over here. They should be equal. That is the answer. Okay. Q equals to 2P. So now this is 1 and this is 2. So 1 into 15 plus 2 into 15. So answer is 45. Same over here. Second, 1 into 0 plus 2 into 20. 1 into 0 because this is 0 over here. And 2 into 20, right? So it becomes 40 now. Again equal, not equal. Last one, Q equals to 3P. So Q equals to 3P. P equals to 1, Q equals to 3. So 1 into 15 plus 3 into 15. Okay. 1 into 15 plus 3 into 15. So what is the answer? 15 plus 15, 3 is the 45. 60. This becomes 60. And next one is 1 into 0 plus 3 into 20. Right? 3 into 20. So that is 60. So now you are getting 60 at this point. So the answer is what? D. Correct? Q equals to 3P. See over here. Again try this problem yourself. Okay? Always try the problems yourself. There is no one else who will help you in exam. Okay? Next one. For an LPP, Z equals to 2x plus 3y, the coordinates of the corner points of the bounded region are this. Okay? The minimum value of Z is, now this is up to you to solve because same problem repeated. X, Y and Z, right? Z equals to what? 2x plus 3y. Put the values of X, Y in each of these and find the value. Try it yourself. I'll give you now 20 seconds. Max to max 20 seconds. You have to solve it within that. Start. I'll wait for you. 20 seconds I'll wait. Okay? You must know the solution. Put 3 3 over here. Here 3 3. second V point is 23, 2010, 1812, E that is 1212, and put the values over here. Solve it yourself. Let me see who comes first. Now the chocolate again. Chocolate goes to whom? Chocolate goes to whom now? Whom? Okay, that chocolate is in the mind which I give you, right? That is a sweetness in the mind. Okay, because physically I can't give you. So take it yourself only. The main point is the satisfaction or the sweetness of solving the problem. That is the main chocolate. Okay. So what is the answer you are getting now? Come back, everyone. Yes. You must get this answer, because otherwise what happens, all the problems which you have solved up till now is a waste. Okay. Get it simple. So the answer is B. This 15 is the answer. Okay. The minimum value of Z is 15. You solve it, everyone solve it yourself, and you must get this answer as 15. Okay. Done. Last problem for today. How many of the following points satisfy the inequality 2x minus 3y is greater than minus 5? So again put all the values here, x and y, solve everyone. I want everyone to solve. And z, don't write z over here, just write 2x minus 3y is greater than or equal to minus 5. I'll show you example of 1. Okay. Let's put this first one, 1. So 2 into 1 minus 3 into 1. 2 into 1, x is this, 2 into 1 is 2, 3 into 1 is 3. So 2 minus 3 is minus 1. Minus 1 greater than minus 5. Is this the correct answer? Is minus 1 actually greater than minus 5? Does anyone know this? Yes, this is true. So this point satisfies, 1 satisfies. Second one I'll show you. Minus 1 and 1. So 2 into minus 1, minus 2, minus 3 into 1. Okay, so minus 3, right? So minus 2 and minus 3. So that is minus 5. So minus 5 is greater than minus 5. Is it true? Wrong, right? So first satisfies, second doesn't satisfy. You try it for everyone. Again I'll give you 10-15 seconds. Okay, 15 seconds is the maximum time I can give you for this problem, because in exam also you have to solve with this speed. Start. How many points? Let me see. Okay, how many points? It's very easy. Just solve them and you'll get the answer. Okay. Tick tick 1, tick tick 2, tick tick 3, tick tick 4, tick tick 5, tick tick 6, tick tick 7. Okay, coming up. All are coming up now. Yes, some of you have solved it. 8, 9, and last one is 10. So the answer is B. 5 points satisfy this. 5. How many of you have got 5? Type yes if you have got 5. Don't type fake. Type yes if you have got the answer as 5. Okay. Type yes. Yes. Many of you have got it correctly. Okay. Okay. So that was the problem. Again, I would say we have a prime pack, CAIIB prime test pack and JAIIB prime test pack. Go for it, because few days are remaining for JAIIB and CAIIB exam in June, right? 1500 plus questions, 50 plus tests for JAIIB, and for CAIIB 1500 plus questions, all the topics, right? Use the code Y432, use the discount 17%, go for it immediately. Also, I have shown you how to go for that batch which is coming up. Go for that as fast as possible. Okay. So I'll take the leave now. Tomorrow I'll see you again with some new topic, new problems, and see you in